If someone were to give you the slopes of two lines, would you be able to tell which line is steeper without having to draw a graph? So let's take a look at this particular question. Which line is steeper, one with a slope of -5 or one with a slope of -2? We already know that -2 is greater than -5 on the number line. Does that then imply that a line with slope -2 is steeper than a line with slope -5? Well, let's examine that. Over here, you see the graph of two lines. One of them has slope -5 and one of them has slope -2. Obviously, the blue line is the steeper line, but does it have slope -5 or -2? So when you have the graph of a line, you want to find its slope, you can take 2 points on the grid marks and count the actual horizontal or vertical distance, which we often call the rise, and count the actual horizontal distance, which we call the run. This distance right here is a distance of 5, and this is a distance of 1. So the slope for the blue line is 5 over 1, and then because the line is decreasing, we know the slope is -5 over 1. And of course, we always want to simplify these numbers, so the slope is -5. So actually, the blue line, which is the steeper one, has slope -5, not -2. So it's not simply which number is greater makes for a steeper slope. That's true on the positive side, but not on the negative side. So what's true in general is right here. The greater the magnitude or the absolute value of a line slope, the steeper the line. So if you've got a line with slope -5 and a line with slope -2, you don't want to have to draw the lines like we did over here. Instead, if we just look at the magnitudes or the absolute values of those two, whichever number is larger is going to have the steeper slope. So the absolute value of -5 is 5 because it's 5 away from 0. And the absolute value of -2 is 2 because it's 2 away from 0. Now from here, we can tell which one is greater. And of course, 5 is greater than 2. So that means the line with slope -5 is steeper than the line with slope -2. In summary, whether you have lines with positive or negative slope, this is always true. The greater the magnitude or the absolute value of a line slope, the steeper the line. Let's now take a look at an application of slope. Below is Michelle's salary Y in dollars after working X years at the Euler Company. The relationship between her salary and the number of years is linear. Find the unit rate of change of her salary and write it using correct units. Do you see the word slope anywhere in here? No, but technically this is a slope computation because the relationship between the number of years and the salary is linear, and we want to know the unit rate of change of the salary. The unit rate of change is the slope of the line. In general, slope is a rate of change. So far, we've experienced the slope as the change in the rise amount or the change in the y values over the change in the run amount or the change in the x values. And that has yielded a number. Slope has simply been a number without any units. However, when you have a linear relationship between two variables in application form, where the variables represent two different things, in this case, the x is the number of years she's been working at the job, the y is representing the salary in dollars in that particular year, you have units to go with that slope calculation to give you more meaning with respect to the slope rather than just the rise amount over the run amount. And that unit is in the form of a unit rate of change. So let's take a look at this problem. First, we need to find the slope, and then we'll worry about the correct units. It's a linear relationship between x and y. And in this case, we have a table, but these are still, each row represents an ordered pair, 2, 46,000, 5, 51,250, and 7, 54,750. Those are all ordered pairs. And as we've already seen, it doesn't matter which 2 points you use on the line to find the slope because the ratio will always be the same between all points. So take whichever ones you want. In this case, I don't know, let's just take these bottom two. We're going to first subtract the y values. So I've got a slope of 54,750 minus 51,250. Notice I'm just subtracting in this order. It doesn't matter. You choose what you want to, how you want to subtract the y values, and then you have to subtract the x values in the same direction. So I need to do specifically 7 minus 5. So in the denominator, I've got 7 minus 5. Now, I just want to do this arithmetic. 54,750 minus 51,250 is 3,500. 7 minus 5 is 2, and 3,500 divided by 2 is 1,750. So in the previous problems, that's where we would stop. The slope is 1,750. But again, because this is a linear application, there's more meaning to go with this. Notice that this number right here was a change in salary amount. So it was a change in the amount of money. This number down here in the slope computation was the change in years. Because this is a ratio, it's a rate of change. And in this case, the rate of change is you've got the dollars per the number of years. So this 1,750 is the amount of dollar change per year in her salary. And we can often write the per with just a slash, P-E-R. So what this is saying, because it's positive, is she gets a raise of $1,750 per year. So the slope is not simply just some number 1,750. It means her salary goes up by $1,750 per year.